we should likely start because
Western Standard.
Edward is used to Berkeley time and not McMaster time, which evidently is 5 minutes behind at 9:30. We Mark from the Department of Computing and Software, who's going to introduce our guest today, Edward Lee from the University of Berkeley. Mark?
So,
are you going to be interesting, or are you going to read it out?
No, I want to make sure I get this, David. So, he's the Robert S. Pepper Distinguished Professor in Electrical Engineering and Computer Sciences at Berkeley. He's known as one of the world's leading researchers in cyber-physical systems. He's done some extremely interesting work on trying to make computing more deterministic in terms of timing with his PRET architecture, and has also done really interesting work in terms of how you model these types of systems. This Ptolemy 2 sort of set the standard for how you can create a language and a way of modeling systems that engineers can actually use and understand, but also has many great properties in terms of being able to verify and promoting good modular design. It's a real pleasure to have him here. He gave a wonderful talk yesterday on modeling and trying to create deterministic models, and I think we're very lucky to have him here today. Thank you very much.
Thanks, Mark. So let's welcome so Edward, this is not a technical talk, sort of chat. The way CafeX works, the cafe opens, and then once we're done, the cafe closes. But people are encouraged to have coffee and cafe snacks, and it's one of the highlights of McMaster engineering life to have interesting CafeX guests who leave us enriched. So that's the bar that we set for you.
Okay, I will try.
Your very best.
My very best.
Today's topic is symbiosis or annihilation. Can technology and humans coexist, or something of that nature? But before we go there, let's find out more about our guest. So, who's Edward Ashford Lee? What are his dreams and aspirations? And what brought him to this point about writing about Plato and the nerd and so on?
Well, let me first say that this is an unusual event for me. As Mark pointed out, most of my career has been very technical. I've written actually several books that are textbooks, and no one ever invites me to talk about my textbooks in this kind of forum. They're of a very different nature, and perhaps for most people they're a good cure for insomnia. But in the beginning of 2016, I set out on a project that was completely new for me, which was to write a book that was intended for a general audience to try to help us as a community. Really, in many ways, I'm speaking to me and my colleagues, but also to the broader community, to try to help us to understand what the process of creating technology is really all about. And one part of the motivation for this was actually a certain amount of trauma that happened at Berkeley when we, like McMaster, have been under a lot of pressure with shifting student interests and in particular technology-driven focus on computer science and related topics that has sent students to us in droves, driving. I mean, our introductory computer science class, I think the offering last fall, had 1,700 students in it. And the largest classroom on campus holds 800 students. So, we had to negotiate with the fire marshal to find ways to actually offer this class. And so, as a community of technologists, we've been under enormous pressure, and a lot of the discussions that were happening among the faculty about how to react to this made me realize that most of us, myself included, didn't really understand what engineering was. And so I set out to try to investigate that, and it resulted in a book that is intended to be readable by any literate technologist, I would say, or a numerate humanist. I mean, it does have a little bit of math, so if you're a pure humanist who runs screaming from the room when anyone mentions math, it might be a little bit of a slog. Although I have to say, my most important guinea pig on drafts of the book was my mom, who is 84 years old, and she's a musician by training, and she's allergic to math. And she read the whole book, and she gave me very detailed feedback about where she was getting lost, and I think it helped me quite a lot in sort of refining the content to try to make it accessible to a broader audience. But it's really my first attempt at this kind of thing.
So, just leveraging the title Symbiosis on Annihilation, having a conversation with a colleague, John Preston, and he mentioned to me that some of the brightest technologists essentially says that we've lost, our future is bleak. Elon Musk thinks AI and machines are going to take over. Bill Gates thought that for a while. Stephen Hawking says that the game's over. Why are we having this conversation?
So the subtitle of my book, I think, is maybe most reflective of its content, which is the creative partnership of humans and technology. And one of the major themes in the book is developing this idea that technology is actually co-evolving with humans. And I have to be a little bit careful here, because when I talk about evolving, I'm not so much talking about the genetic evolution of humans. I'm talking about what you may know about Richard Dawkins, who wrote this fabulous book called The Selfish Gene in the 1970s. And he coined the term memes for the units of replication of ideas in cultures, right? So he talked about a Darwinian evolution of cultures through this notion of memes, where memes were, he chose the word very carefully to be analogous with genes, and he was talking about sort of the competition and mutation that arises in cultures around ideas and propagation of ideas, and even very fundamental sort of human technologies, in a sense, like language and writing, are a very big part of this evolutionary process. And in developing my book, I read a book that had a huge impact on me, written by George Dyson, called Turing's Cathedral. And this book is actually a history of computing, and it's very much about John von Neumann. And the title says Turing, it doesn't say a whole lot about Turing, it's more about John von Neumann. But Dyson, in this book, planted a seed of an idea in my head that technology is actually engaged in a symbiotic coevolution with culture. And it's a very Darwinian coevolution. And it made me realize that the way that I had thought about technology for all of my career, which was that as a technologist, I invent things and they come out of nothing, and I invent ideas that contribute to a sort of pre-existing body of knowledge, and I add to the body of knowledge. That was actually a complete misunderstanding of what I've done in my entire career. I've come to realize that what technologists actually do is that they're the force of mutation in an evolutionary process, and that the things that we create are variations of things that were there before, and most of the things we create don't survive. They don't survive the competitive marketplace, and a few of them do survive. And we think of, we like to think of the ones that do survive, we think of them in retrospect. We don't see them in the process of going through this competition and survival. We see them in retrospect as sort of obviously the thing that should have happened, but that's not really the way they came about. They came about in a very evolutionary process. And I think if we understand that process better, we're going to be in a much better position to be able to manage that process. So for example, You mentioned the doomsayers like Elon Musk, right? He says that AI is an existential threat to humanity, and he thinks we should regulate it. And I think that he could be right. I hope not.
Me too.
I think that the idea of regulating something we don't understand, however, is really a bad idea. And so part of what I'm trying to do in this book is to get a conversation going so that we can better understand what's actually happening, because without that understanding, I don't think we should even be talking about trying to regulate it. And as far as the existential threat to humanity, I think that if you understand what is happening as a symbiotic coevolution, the symbiosis is actually a force towards, it's a positive force for humanity, right? Because it says that the technological artifacts that we create that are more likely to survive are the ones that benefit the people who are going to nurture and develop that technology.
Edward, can I interrupt you there and ask you? You said that how can we regulate something that we don't understand? Don't we often regulate out of a lack of understanding? We regulate out of fear. So we regulate Bitcoin. We don't understand its impact. We regulate the sale of marijuana. We don't really have a good understanding of the societal implications of not regulating it, or having it completely free. Many regulations are emotive. There are countries that are regulating refugee influx and immigration based on religion. So regulations sometimes are driven out of fear and irrational responses, aren't they?
Yeah, regulations are actually cultural artifacts. And following Dawkins, they also come out of an evolutionary process. And they, are often arise from random mutations that may be driven by fear, and they are not rational necessarily, designed things that come about for necessarily for good reasons. So you're absolutely right about that. I think that we're seeing a certain amount of the effect of regulation and culture in AI. So I had this interesting experience while I was working on this book that I happened to see a flatbed truck that had a car on it that had the front end of the car was completely smashed. And it was a pretty late model car. It was probably a 2016 or 2017 car. And I had this reaction that surprised even me, which, my first reaction was that car should be ashamed of itself. Why? Well, because I think we have no excuse today for putting cars on the road that will happily run into the car in front of them at 60 miles an hour. Mm-hmm. There's no excuse for that, actually. And yet, so I talked to executives at car companies about why do they do that? And they even do this with cars that have all the hardware and software on it to prevent it, right? They have adaptive cruise control systems, but if the cruise control system's turned off, the car will happily run into the car in front of it. And, the executives from the car companies, sort of hem and haw about, liability laws and regulations and so forth. And it is liability laws and regulations that are in fact defining how we're deploying technology in this space. And so the technology here is very much in this tightly intertwined dance with, between regulation, technology, and culture. And we can't avoid that. I think I think as a technologist, I used to naively think, okay, we just, solve a problem, like keeping cars from crashing into the cars in front of them. And once we've solved that problem from a technical perspective, our job is done. And I realize now that's not true.
So you live in one of the most dynamic innovation ecosystems in the world, Bay Area, Silicon Valley. You see the symbiosis there?
Absolutely. I think that, George Dyson expressed this very well in Turing's Cathedral. He talked about a visit that he made to Google, and where he learned about their server farms, and he said they've got millions of servers that are all, running these software services that we all take for granted. And he described these servers as a vast metazoan organism, so a multicellular organism. And in many ways, that's not a bad analogy. It does function almost like a life form. Right? It sits there reacting to stimulus from its environment, providing stimulus to the environment. It needs nourishment. Its digestive system is power plants that consume fossil fuels mostly, right? And you can almost think of it as a living thing. But the thing that Dyson pointed out was that it exists because, in part, it provides benefit to the engineers and the Google infrastructure that nurtures and develops it, right? That it would not exist if Google had failed as a company shortly after starting up, right? So there is a symbiotic relationship there where the software systems are supporting the humans who are developing and supporting the software system which is then supporting the humans. And then I started to realize, I do a lot of software development myself, and I use Google quite a lot and my software productivity has gotten vastly better through the use of these software tools. And there's this strong feedback loop.
Edward, what if I challenged you? And I threw cold water on what you're saying, saying that Dyson and you...
literally.
What if I said that Dyson and you were poets? That you're using metaphors. A living thing is a living thing. Give me a break. You're talking about metaphors. I mean, Homer used them, Shakespeare used them. You're writing poetry.
We are talking metaphors. I think Dawkins was talking metaphors when he talked about memes, right? And yet it has actually, he has provided us with a very useful way to think about how culture develops. So metaphors can be useful as a way of structuring thought. But I'd like to also point out that these technological artifacts are actually much closer, it's a much better analogy than memes. Memes cannot exist without the human host. They're simply, the words on a page you can think of as encoding a meme, but they're useless without a human reader. But the software systems that we're creating are actually capable of a certain amount of autonomous existence. They can sit there for a while without human help and react to stimulus from their environment. So they actually resemble human things more than memes do. And so if Dawkins' analogy is useful, I think mine is even more useful.
Okay, let's pivot to a statement that you made earlier, that you previously thought that creation or technological creation, scientific creation was additive, that it grew out of a rational, systematic, logical process, whereas now what you say is, now what you realize is it's an interplay of emotions, culture, and so on. I have these discussions with this man over here in the front, a barber. I have lunch with him once every 2 or 3 weeks, and he thinks I'm interested in the conversations, but the reasons why I meet with him is that I'm mining all those lunches for a book I'm going to write when I'm on sabbatical. It's going to be called Lunches with Doug. And I'm going to need a lot of money because I know who my customer is. But Doug talks a lot about what we miss out in technology. It's the emotional, it's the value-driven, and value in terms of emotional and human values, good versus bad, and so on and so forth. Do you have any thoughts about that?
Yeah, I do. I'd like to start by quoting Donald Rumsfeld, who I don't quote. As you know, he was.
I think we're well aware of who he is.
Right. He was the Secretary of Defense under W, as we know him in the U.S. And this was during the Second Iraq War, when he talked about his sort of famous speech about the unknown unknowns. Right? He says there's the known knowns, there's the known unknowns, but the real threat, is the unknown unknowns. Well, he missed an obvious fourth category, which is the unknown knowns. right? These are the things you know, but you don't know you know them. And we all have them. And in fact, they very much form the backdrop of our thinking about anything we do, right? And so this idea of technology development being a purely rational, logical, systematic accretion of knowledge sort of process is probably wrong, because most of what we do in any of our intellectual lives is very much predicated on these unknown knowns, which is this backdrop of ideas that form our thinking, shape our thinking. And of course, the person who best articulated this, I think, is another Berkeley professor, Thomas Kuhn, when he wrote in the 1960s.
About paradigms,
the book about paradigms, the structure of scientific revolution. And he was talking about science, right? The role of these unknown knowns in science. Whereas in my book, I'm talking about the role of these unknown knowns in technology. And it's a little bit different than Kuhn's take on it, but the effects are very much the same. Our thinking is very much shaped by these unknown knowns, and we need to recognize that. It's not pure logical, rational deduction.
Let's talk about something Canadian. Canada, as you may know, not much reporting about Canada in the LA Times or the local Bay Area newspapers, or on MSNBC or Fox News. But you may know that Canada has aspirations to assume AI leadership in the world. And there's a man who's given to grand statements. He's not a poet. His name is Vladimir Putin. And he stated that whoever becomes the leader in AI will become the ruler of the world. You see Canada as the ruler of the world?
Well, I think the U.S. seems to be doing everything in its power to help Canada in this regard. We're systematically working to drive away all the world's talent, and a natural alternative for all that talent is to come to Canada. And so you should be thanking us for this, because it's going to help Canada become the ruler of the world. And I mean, I think that Putin has in fact a very valid point, and I think that AI is a very powerful tool. I personally prefer to think about IA rather than AI, because I think what we're developing is better described by this notion of intelligence augmentation rather than artificial intelligence. I think that the AIs by themselves, we think of these image recognizers and classifiers, for example, as being artificial intelligence because they seem to be doing things that are similar to what the human brain does in classifying images. But the whole reason that we have them is to provide us with tools that will do things like, sort all ancient pictures or search for pictures of people by name or things like that. So the reason that we're creating them is actually to provide services to humans that will enable us to do things that we do better. And in fact, the technologies that are being most successful are those that are in fact demonstrably providing some useful service to humans. So if you think of the technology that we're developing more as IA, Putin is very right that intelligence augmentation in the hands of nefarious people can have pretty disastrous consequences. And so,
is that preventable?
I hope so. I think that culture is always under threat from all kinds of things that are happening. It's the nature of the human condition. Lots of things that could go wrong, and history has certainly demonstrated that things do go wrong. I feel incredibly privileged actually to live in the time that I live in, because I think my adult life has been uniquely peaceful in human history, in the sense that if you look at it from, obviously it's not been perfectly peaceful, right? That hasn't happened yet. But if you look at it, from the perspective of the percentage of the human population that has been engaged in or affected by warfare, I don't think it has ever been so peaceful in history, in recorded history, as it has been during my adult life. And I think that part of the reason for that actually is technology development.
And yet, the United States has a huge military machine.
It does.
Is that what it takes to bring about peace?
I don't know. That's a policy question that is beyond my expertise. I
Or just leveraging the peaceful, that term. I suppose because we're talking about cultures, I would say that conceptions of peace could be different in different cultures, and those conceptions come with consequences.
yes.
Take WikiLeaks, Edward Snowden, huge apparatus that also touches upon technology.
Yeah, absolutely. And I think that, ultimately, it is humans and human decision-making that can disrupt peace. I think we're not at a stage where technology alone will do that. I think it is in the hands of humans. I hope it stays in the hands of humans. Although humans are far from perfect.
In this context, we touched upon fear, but technologies also bring fear. Technologies bring surveillance. Surveillance imposes fear. It imposes cultural behaviors that might be unnatural. That is, people may wish to say or do something, but may be afraid of doing so because they're being surveilled and they're afraid of the consequences of surveillance. And that touches upon computing, touches upon server farms, touches upon AI, or IA.
Absolutely. I think that fear is a tremendous driving factor. One of the things that I think a lot of people are very worried about is their careers evaporating as a consequence of technology development. And careers are means in the Richard Dawkins sense. They're cultural artifacts. And if you think about it, all these Uber drivers are afraid that their careers are going to be obliterated by technology. But they forget that their careers are only 4 years old, and that they were created by technology. And so there's this feedback loop where these cultural artifacts like careers are very much intertwined with technological artifacts. And if you think of this as a coevolutionary process, I think the thing that scares people the most is that it's an evolutionary process that right now is happening very rapidly. And and one of the interesting things about Darwinian evolution, it's there have been periods in history where biological evolution has been relatively rapid. So there's the famous Cambrian explosion, right, which was some, I forget how many millions of years ago, maybe 250 million years ago, where there was a relatively short period of time of 10 to 20 million years where apparently the Earth went from having only unicellular organisms to having a really very, very large number of species of multicellular organisms in a very short period of time. And there's a wonderful theory called the light switch theory about why this came about, which says that it came about because of the development of eyesight. In essence, cells developed the ability to see in a rudimentary sense initially, but what this enabled was predation. Predation is about killing and eating, and this is what accelerated evolution was, this ability to kill. It actually, predation accelerates evolution because it wipes out a lot of species. Rapid evolution is intertwined with death. It happens, it's necessary, it's part of rapid evolution. And we're seeing that kind of thing happening where we have memes like careers that are very much under threat, and many of them will go extinct. Many of them already have. You can name quite a few careers that have just gone extinct.
So is the analogy to seeing data analytics then, in a way?
I think that's a potentially Potentially, yes. So this ability to suddenly have this, it's like an eye-opening thing, right? To be able to analyze huge
Forecasting.
amounts of data.
Yeah. Well, we're at the almost the half-hour mark, which is when we open it up to the audience. This has been a fascinating conversation. We're not yet done, so we'll invite questions from the audience. Who dares oppose? Oh, John Preston does.
So I'm going to start with a statement that I think we agree upon from comments that you made, which is that there's no reason to think that an evolutionary process or a cultural evolutionary process is in any way close to a thermodynamic type process. That is, there's no reason why we have to end up where we do. It's just processes that guide us. Given that, I wonder about your statement that the coevolution of technology with people inevitably is moving people in a direction that's positive for them. I mean, it is positive in the short term, but I think many species have evolved themselves into a niche that has then disappeared and they become extinct. And so why is it not possible for humans to do that in our coevolution with technology?
I think it very much is possible for humans to do that, and that may be how it plays out. What I was saying simply is that symbiosis is a force in a direction that is potentially helpful. And I guess the analogy that I would draw is, we live symbiotically with our gut bacteria, and in fact, I would put technology versus humans roughly at the same ratio as humans to gut bacteria, right, in sophistication, right? I mean, I think the technology we have today is very, very primitive compared to what we'll see in the future. But our gut bacteria, for the most part, work very well with us. But occasionally things go wrong, right? And we do everything in our power to kill off the bacteria when the things go wrong, because the symbiotic relationship is the force that wants us to keep the gut bacteria in check so that they're operating beneficially to us. And in the evolutionary force, when they stop operating beneficially, it doesn't serve them very well either, because we will react by trying to kill them off. So that is a somewhat stabilizing influence. It's far from perfect, and there's certainly many biological examples of evolution that have been dead ends, and so we could find ourselves in that situation.
I want to make a comment about killing off the gut bacteria, because it's absolutely correct, and I think there's a strong analogy or metaphor.
Because I've been inspired by this to poetry, just like Homer and Shakespeare and all were.
Yeah.
So if you take the gut bacteria as our biome, and we carry biomes externally also, each of us has a very unique biome. We have like a little covering of bugs and bacteria that we carry with us. Carry it on a plane, you carry it back to Berkeley, it'll be uniquely yours and your signature, and also within yourself in the gut. So, I mean, the poetry that I've been inspired to generate through metaphors is that maybe we all carry a unique biome of technology, right? The device in our pocket, how we connect each other.
Here's the third half of my brain right here.
No, and the other piece of that is, it's just as in with the biome in our gut. If something goes wrong, right, we just try to shut it down and kill it. And we do that because we have this mystical belief that if we do that it will somehow restore itself and everything will be terrific. And I know I solved a number of problems on my computer last night simply by turning it off and allowing it to reboot. And everything came back up and was working correctly again. So I think there is a similarity there.
There's also another similarity, which is that when you have problems with your computer, often you will go to Google, enter in the whatever the error message was, and Google will help you fix the problem, which means that you are functioning as part of the immune system for that software that has gotten some disease that is making it malfunction. What do we mean by disease? Well, disease is some kind of malfunction from some deviation from what you expect. right? But there's no clear boundary between, disease and growth, for example. We know of that in, the phenomenon like cancer, right? But the fact that humans can operate as part of the immune system for the software systems, and of course, the reverse is also happening. How does your doctor diagnose what's going on with you? Well, he uses computers pretty intensively these days to try to help them figure out what the appropriate course of treatment might be for whatever is going on with you. And so there's this feedback again.
Mark, you asked a question yesterday and even today, double dipping, man.
So you talked about careers that are going to go away with this technology. And do you have any insight on which careers you think are the ones that are going to go away? There's the obvious ones like maybe truck drivers and stuff like that. But I mean, what about, let's say, in terms of engineering careers or doctors and stuff like that? Do you see still the need for
professors?
Yeah, undergraduate instructors gone.
Well, but just in general, I mean, so should we be telling our children, go ahead and go into engineering, or is that engineering design stuff going to go away, but it's going to be replaced eventually by the technology that is better doing itself?
Well, I think the one thing I can say is that the future of a rapidly evolving process is very hard to predict. I think that these systems are chaotic, which means that you get arbitrarily large effects from small perturbations, and that means that you really can't predict the future very effectively. But I do think we can learn a lot from just looking at recent history. What careers have disappeared already? Well, we don't have clerks anymore, right? I mean, that is kind of a position that doesn't exist. We don't have travel agents, except for really occasional niche kind of functions. There are a bunch of careers that have disappeared, and there's some that are, very clearly on the horizon for near-term threat, such as truck drivers. I think that is one. But looking further into the future, I think, is extremely difficult, in part because I think the recent history has also shown us that the technology creates new careers, right? I mean, there was no such thing as an Uber driver 5 years ago. And yes, we had taxi drivers, but actually that was a significantly culturally differently structured career, right? And nobody anticipated, I certainly didn't anticipate that. I think, if you look back, get all the smartest people in the room and try to predict what the career landscape is going to look like 10 years from now, they're going to get it wrong.
And in this background of symbiosis, how should computer science software engineering curricula change? Should they adapt it? Shouldn't they? Or have they adopted it?
I think that's a wonderful question. I think one thing that I would like to see is a little more humility in how we present the technology. We talk about teaching students to code, and most computer scientists will have a religious devotion to a particular programming language. They don't realize that that programming language has strongly structured their own thinking processes, right? The language affects their thinking, and they think that somehow they're going to do the students a huge favor by getting the students to think that way too. And if they had chosen a different programming language, they don't realize that they would have actually gotten the students thinking in a rather different way, right? So I would like to see a little more humility in what we present, and part of that is also giving the students, when we teach them about technology, we should not be teaching them that these are facts about the world that you need to learn. We should be teaching them that these are human inventions that were created by sometimes quirky people. Who created Python? It was a bunch of individuals, creative people, who created a language that works. It has personality. We should teach the students about that personality, about the people who brought about that technology, because it'll give them a better understanding of what's likely to come down the pike, which is going to be pretty different. They're going to experience things that are very different from what we experienced, and we need to prepare them for that change.
Doug?
Yeah, I think it's a simple question. What are beliefs, and how do they affect things?
That is not a simple question. I'm not a philosopher.
You sound like one. You play one on TV, you're on Facebook Live.
I think that's a wonderful question. I think it's actually, I would characterize it as a very deep question about what goes on in the human brain. I think that, nature has given us this magnificent machine that has a lot of very interesting properties. Many people these days assume without question that machine is just a computer, and if we get the software right, we can replicate what that machine does in software. I don't buy that. Actually, if you realize that, computers, as they're designed today, are capable of some truly remarkable things. But if you look at it even just from a foundational theoretical perspective, the things that they are capable of is a tiny, tiny subset of what, in principle, we know is possible in nature. It is a very tiny subset, so it would be truly remarkable if somehow nature had restricted itself to that tiny subset in the process of creating our brains. I don't believe that it has, and so I think that we shouldn't underestimate the power of our brains and think that they can just be duplicated by computers. I don't actually think that that's probably true.
I just wanted to add, I think that beliefs are central to culture. And you talked about things that you have that you don't know. And I think one of the big areas is we don't all know what we believe until it gets tested somewhere.
Yeah, and yes, absolutely. I've been actually trying to learn a little bit from the neuroscience community about how the brain structures knowledge, and there's some wonderful theories that are based on Bayesian probability, which is essentially that the brain learns from experience it learns to expect certain things. And the things that you sense are the things that deviate from those expectations. That you don't actually sense the things that match your expectations, because that would be very inefficient, right? And so the things that you sense are the things that deviate from your expectations. And I think your beliefs in this theory are your blind spots. They're the things that actually determine what you don't sense. Okay?
Very interesting answer. Yeah, right in the back.
Like whenever the intelligence is there or decision making, you have humility, which is actually which should govern your intelligence, decision making, this kind of thing. So for AI, like Isaac Asimov, in his science fiction, he proposed 3 laws of robotics. And he said that these 3 laws should always govern whatever robot or artificial intelligence is built. Do you think this is the time that we should think about how AI should proceed?
I think that's a very good question. I think that Isaac Asimov's laws are too simplistic, right? I wouldn't have any idea how to codify them, and I wouldn't have any idea how to enforce them. And I don't think that the answer is going to be to somehow refine Isaac Asimov's laws and develop some international treaties that codify them. I think it's naive to expect that that'll have much of an impact.
But he was a good writer.
He was a very good writer.
Okay. One or two other questions before we let Professor Lee get on with his day.
What's up?
Yeah.
In the book, Homo Deus from Yuval Harari.
Could you speak up a bit?
The book from Homo Deus, Yuval Harari, his name is this. 2016 is his last book. He says that separating the intelligence from consciousness, and we think the living being is like a data processing units. What do you think about that?
A beta processing?
Data processing units. Every living being, according to the book, is a data processing unit. With the human, the plants, everything, when they die, they stop processing data. And then we are going toward like a unit of data processing.
I love that book, by the way. Harari's book is a spectacular book, Homo Deus. I really recommend everyone should read it. He is a complete iconoclast. He pulls no punches in this book. There's a lot of very interesting, very controversial points he makes in it, some of which I don't quite agree with, but every one of which I respect. A really good book. I think that there's a risk in this notion of everything being data processing, of assuming that what we mean by that is what computers do today. So what computers do today have two key limitations. One is that the data that they operate on is digital. Okay, it's very discrete. And second is that what they do in operating on that data is algorithmic. It's step-by-step operations. The steps themselves are discrete. We have no convincing reason to believe that the physical world has either of those limitations. Okay? The information in the physical world need not be discrete, and the processes that operate on that information need not be algorithmic in the form of being step-by-step operations. So people that assume that just because if you could accept Harari's point that everything in nature is processing information, but it would be an erroneous conclusion to conclude that it's processing information the way computers do. That conclusion is indefensible. And a certain amount of the math in my book is actually showing why it's indefensible. And I'm obviously not going to give you that here, but you'll have to read my book to get that.
So I think that we've had a very rich session. The cafe will stay open. I encourage you to stay and mingle with Professor Lee. Have a cup of coffee. We don't have decaf. If you like decaf, you're out of luck. There might be a water fountain down the hall. There's plenty of carbohydrates. There's some water. There's some sodas. So stay, mingle, make new friends, meet with our guests. And because we're in a university, every session should end with an assignment. Doug Barber said that, what about beliefs? And Edward's answer was, well, beliefs have to be tested, but they also, once you test them, they reveal your blind spots. So this is a cafe more about metaphysics than technology. So your assignment is to look at 3 world leaders and decide how you're going to test their beliefs and find out what their blind spots are. And those 3 leaders are, because we're in Canada, Justin Trudeau. We mentioned Vladimir Putin. What are his beliefs and what are his blind spots? And let me throw, just for fun, Donald Trump. How would you test his beliefs and therefore find out what his blind spots are? So you have your assignment ahead of you. Feel free to submit it to me. You can find my email on the web. We'll post them publicly on a website. And we might crowdsource the first prize. But join me in thanking Edward Lee, the really, really interesting author of Plato and the Nerd, the creative partnership of humans and technology. He wants you to read it, MIT Press, 2017. Edward Lee.